Our next keynote speaker is Nicole Argent. So Nicole is an environment and sustainability manager at John Holland. She is passionate about challenging traditional practices and driving innovative solutions to reduce the construction industry's reliance on finite resources. She leads initiatives such as using recycled materials, exploring renewable energy, and implementing sustainable practices, fostering positive change within John Holland and the broader industry. So please join me in welcoming Nicole.
Thank you very much. So this morning I'm going to talk you through a project that we completed here in Melbourne on Hobsons Bay. It is the first construction project in Australia that was net carbon neutral for scope 1, 2 and 3 emissions. So to meet the carbon neutrality for the scope 3, we had to develop a way to track our materials efficiently, as it was a very small project with very limited resources. So why is scope 3 so important? So the construction industry is dominated by scope 3 emissions when you look at the work we do. Our scope 1s come from our equipment, trucks, dozers and excavators. Scope 2 is the energy we buy to power our sites and such as tunneling bore machines. And scope 3 is our vast majority of the emissions, which is what goes into the infrastructure we're actually building. Those are the emissions which are embodied in the materials that we use. We need to calculate how much energy it actually takes us to make our concrete or how much carbon is in our steel, which is actually a significant portion of the materials we use in most projects. We have to divide those emissions into our construction works and try to understand where the energy went in it. By doing this well, we can work to reduce emissions by putting pressure on our supply chain and changing the way we build. It is critically important for our clients to actually understand where our scope 3 emissions are as well. So we all, as previously mentioned, we all are upheld to the Paris Agreement, which holds us accountable to reduce 43% of our total emissions by 2030 Australia-wide. Traditionally, we think of net zero targets as a nation, which relates only to scope 1 and 2 emissions, and we've had 15 years practice in reporting these. The introduction of mandatory reporting for scope 3 emissions is providing the new challenge, and it's happening now. The federal government has legislated its treasury laws and amended that all companies above $50 million in revenue must declare their scope 3 emissions. Within the water sector, this requirement has flown through to our clients, and water authorities across Australia now have requirements for their projects to map and report their scope 3 emissions. Our operations need to be able to keep track of the scope 3 emissions and also report on them, which is quite the challenge. Here in South Australia, SA Water have a net zero target for 1 and 2 scope emissions and for 2030, and they're looking at their scope 3 reporting emissions, and they'll have a target for that as well pretty soon. So scope 3 in construction is pretty complex. Unlike a bank or an airline, where you can quite easily see your scope 3 emissions from what you've purchased directly from your invoicing register, construction is a little bit more different. The complexity is found around the number of subcontractors found on a building project. There could be up to 20 to 30 different contractors who build on behalf of a client, and these subcontractors need to keep track of their data and then report it to us. This provides variation in the quality of data that's collected and how we actually receive it. Supply chains can be hesitant around reporting because it can expose wastage and margins that companies are making. And also it's complex, as some subcontractors only have a small portion of work and they don't have the resources to actually collect this data in a certain way. Beyond that, we have a lot of small businesses such as a plumbing contractor who may not even understand what we're actually asking them. To add to the fact, across the nation and the world, there is no one system, no standard language or reporting program that people know how to do. Every single construction company, principal contractor or water authority and even road authority will have their own system for reporting. This creates a complex system that is getting quite expensive, and essentially more companies will now consult their way out of this. You end up having consultant carbons roles embedded in projects, which is extremely expensive way of doing things, and the focus is only on reporting and not necessarily on reducing carbon. So what do we do? So from a systems thinking point of view, If you have a really complex idea like Scope 3 emissions, you need to report, then you can either do two things. You can get better at juggling, or you can hire somebody else to help you juggle. In the construction industry, we've been doing the second option, which is helping somebody to help us juggle, which is actually probably a lot easier. But in actual fact, we should be looking at developing systems which are as complex as the systems we're trying to manage and have them to solve our way out of this problem. So, John Holland, we believe we've solved this problem through and have held our supply chains and our clients accountable on reporting on carbon and costs and program as well. So the system we developed takes in information from lots of different sources and standardises it into a rational database. It provides consistency across consistencies across the jurisdiction, and you can put different authorities' clients' workflows into it, and it means we can be flexible and consistent. It has real-time access so people can understand what is going on site, and you don't need to implement strict auditing to make sure you have the right data. You can see if someone hasn't reported properly. It also has inbuilt emission factors and carbon numbers that have been decided to be put in there by the client. This means everyone is reporting the same way and is controlling the carbon accounting. So, Hobsons Bay, they won some awards as well for this. So the project that we built, the focus was on to meet Scope 3 carbon neutrality. We needed to have a really rigorous reporting structure, as it was audited by 2 independent consultants in order to meet the net zero targets. And to procure the offsets to offset the project, we needed to prove where our emissions were. Our evidence, we needed to go all the way down to delivery dockets and how many people reported and did they report on time. It was a small project. Essentially, one person was resourced for this project to do this. It needed a way of doing this so that it was easy for everyone to do, and we were tracking every single material that came onto the site per delivery. We needed to know who bought it and who they bought it from, because we have to have different subcontracts buying materials and from many different suppliers. We needed to track by unit how many tonnes of sand, how many metres of pipe. We needed to know what day it came in, and it was also useful to know the docket number, what cost code, and if it came and which delivery docket it was attached to. So what we worked out is you go and talk to the accounts team. So when you look at how we invoice and how we collect data to pay people, it has all the information we actually need to calculate carbon. Every company in Australia is actually collecting this information. Once we figured this out, we were able to collect the data to pay invoices, realise that was the location that we could collect all of our data. There was no duplication of work. We weren't paying somebody else to do more work, and our accounts team were quite actually happy to help us on this one. So if you look at the page, you can see we collect the supplier that we bought it from, what day it came in, what cost codes, unit, material name, quantity, and the costs. Once you had this information, we were able to put this into a database that was standardised, and then we attached emissions to each of these, so we actually were able to actually measure how much carbon we had in our project. Once we paid something, we decided that means the carbon had gone into the project, so this was like that adding that real-time carbon calculation to it. So this is the Hobsons Bay spreadsheet. We built it up, so it's now into a database. So it started off as a very simple spreadsheet, or maybe not very simple, it's very complex. You can see here we've got the docket reference in the column, and there's different ways the materials came into our database from the accounts team. When we had a new material come in and it wasn't associated with a carbon number, we would actually add to the carbon library. So that information would either come from a stock standard carbon source, which are available free online, or we actually had environmental product declarations to provide that detail. We would choose that new material, attach that information to it, and then once we'd done that, we didn't actually have to map it again. So once we had the docket, and it worked pretty well. So this is how we were doing the tracking, an example of it. So you can see the carbon is tracking through time, and we can track by the material, the diesel or the concrete, and by what supplier we bought it. We can track the contractor who bought it. You can track what design package that it was associated with, all the cost code. Once we collected all of these metadatas tied to the deliveries, we could understand the carbon without really needing to pull out of a spreadsheet ourselves. And so this is another example of the data coming in from the accounts team into the other spreadsheet. So, flowcharts of the actual program and how it works. So this is a simplified overview of what we call the project pathway. In an ideal world, our client would develop the tender documents because they were going to go out to market and they would have estimated their carbon. So you can see that at the second tender phase. They award the project and then the project pathway starts. And through the design phase of the project, we are trying to design and develop what the project will look like as we go through the design gates, which is like your 30, 60 and 90% design gates. So when you're going through those design gates, you would assess the carbon within the project, and that's when you're focusing on that reduction in carbon. Then eventually you get issued for construction and you actually get to know exactly how much tons of steel you have, how many cubes of concrete are going to be there, and you can understand and forecast the embodied carbon of your actual design. Once you have this baseline, you can track when you start the building of the project. And essentially, the design process is the most important part of the construction project for reducing carbon. Once you get past this, you lose certain opportunities to reduce. So the next step is to collect the data from your deliveries and put them in the cloud. You are then able to compare your carbon costs for the building. For example, you can compare the carbon that you expected to have in the building and what is actually delivered. You may at this point identify wastage of materials, and you begin to look at behavioural decisions on site in trying to influence this. Then the data is in a database. You have the embodied carbon in the project, which can be broken down and used for the next project where you can potentially make more efficient decisions. So we've moved from our spreadsheet and now we've gone to a carbon materials tracker. So the next project. So we're now building the resource recovery and reuse complex on behalf of Melbourne Water. So from Hobsons Bay's complex spreadsheet, we've moved to a SQL Server rational data model for the latest project. This is the database. So the delivery is at the core of the table of the database. Every single delivery comes in as a single entry into our database, and we capture material ID, quantities, costs, where it's going on the job, one entry for every delivery, which delivery ties to an invoice. The invoicing software then matches to the materials library so you can track the concrete you bought, what SEM content, what was its emission factor. And once you have those two databases and a full list of materials and the delivery on per entry, you can figure out the carbon as you times the quantity by the concrete from the library. Then to make it more powerful, you can link this to all the subcontractors working for John Holland or any company. You can search by SEM because it's an attribute in the table. As soon as you build the schema like this, and as long as you're putting the data in with some hygiene, you only need to put it in once. You can always be able to pull from it in different ways. So this is our current track deliveries spreadsheet. So as an example, the contractor for this is John Holland as the purchaser. And we collect what date the material came in, what side of the project, what package, cost code, docket number. Looks like it'd be pretty hard to fill out once a month, but in actual fact, our contractors get this information from the supplier anyway. If you're a wholesale customer, you can actually download something similar from this and copy and paste it in. If you've got a waste supplier, they will send you your waste that you've got each month, and in the end, they can send you in terms of invoicing. Once you've copied the information and have the delivery tracker, then the template you have will automatically upload into the database. You can go one step further and remove this step by building a better database, and you still have to, where you can essentially get rid of even more like people filling in spreadsheets, which seems to be a very good step for this. Okay, once it goes into the database, it essentially look like this. So you can see how many deliveries you had and how many concretes we've had during a day. The database then aggregates and calculates this itself. Then you can see how much you have used per month or per year. You can see the dates you want it to assess by, and you can review how much concrete got delivered, what type of concrete got delivered. For all the materials across the dates from this project, the information can be brought in and it's looked at by invoicing. We then take our invoices and put it into the system. Then we have a regionally accurate understanding of what materials come in the site and what day and how much carbon is involved. So this system has been built on behalf of Melbourne Water, so they actually own this system. And you can use it across contractors. This isn't a John Holland owned idea. This is a Melbourne Water funded idea, and we're hoping to roll it out across multiple different clients. So they own the data and they have ownership over the system as well. The reason this is good is it means that John Holland isn't trying to make our system ourselves and only we use it. That isn't the purpose of this. The purpose is this, that everyone can use it, so even our competitors use it. And if we can give it to our clients to operate, this means the industry will start to use it. Using a system in this sorts of way means that we're able to make a dent in the expensive way that construction industry is going with all the use of contractors and consultants to do this work for us. Other features is that it's based in the cloud, so you can send data to it from anywhere. You can get data from our suppliers, contractors, engineers, delivery registers, other software. Any information that comes out of an IoT device, water and power meters, can be added in. We can separate out the materials, who bought it, what it costs, which means we can actually understand how much concrete went into a bridge, how much steel went into the bridge, and how much carbon was in the bridge. So then when we go to build the next one, we've got a base reference and we can hopefully start to reduce carbon instead of spending all of the time trying to report on it. We have got a good system for tracking material quantities and now has other purposes. It is useful for paying invoices because our system is to track everything by docket number. Then our accounts team can start to approve dockets based off a global system. Then our earned value team, commercials team, can state how much concrete did we get delivered this month and was it what we actually predicted. Have we spent the money we should have, or can we start to see you can start to see if we are on budget or what time based off this sort of system. Have we poured 200 when we've actually only poured 1? This maybe means that we're in delays. You can get insights into how the project is progressing by tracking the material in a standardised way and an automated way. We can then also put hyperlinks so we can click into materials, understand EPDs within it, and mix designs from it as well. It also has lovely Power BI output so we can track in this way as well. So the benefits are generally highlighted, but essentially it's automated and it comes from a system that already exists, which is an invoicing system. Every construction company and subcontractor, all the way down to sole source traders, use invoices to get paid and to be paid in the construction industry. So by leveraging this and attaching carbon reporting information, we can support quantity tracking and costs as well and understand our data better. So the final details. So to get this running, the minimum requirements is that each engineer that runs a package has a system which tracks materials, which you'll always have, as that's how you pay your invoices anyway. So engineers need to track the materials on a daily basis, as this will need to go to the accounts team to pay invoices because they need to check the data material that has been delivered. So as long as the construction companies are doing this, the system will work. You need to ensure that your subcontractors are constantly obliged to report what they are purchasing. With the new changes in legislation for carbon monitoring, this should be in there. What would be beneficial as well for this system is if you know what your estimates for material types and quantities are at the start of the project, is you can use to determine whether you're going to go over or under with your carbon. The principal contractor that wins the job are the ones who need to be responsible for tracking this stuff. It cannot be the job of the client to track this as they are too far removed from the system. So they're the minimum requirements and it's really working for us. And there are different suppliers on this system now, which are down below, so Holsey and Mini Tankers, and some of them are also within South Australia as well, and they're all successfully reporting on this on behalf of Melbourne Water. So here are some examples of the Power BI outputs. You can see how much carbon from the different contractors, different packages of works, you can split it up by material types, and then we can track this against the BAU, like business as usual in comparisons. And then your basic NEGAs reporting is in here as well. So you can see what's used on site. Energy meters are plugged in and we can monitor the water usage and fuel usage. And then we can look at the waste tracking as well. Concrete always gets the starting role because it's the heaviest, but also it can then, because of this, the waste is also very interesting because you can see what your wastages are and are you actually purchasing too much in the beginning. Thank you.